lesson. We're continuing on in our Chapter 8 investigation where we're looking at advanced topics in trigonometry. We've up to this point discussed the law of sines, and today we're going to talk about the law of cosines. So I have a couple questions here. The question is, what is the point of the law of cosines? Well, the point is, law of sines doesn't always work. As we've seen in class, if I have a triangle that's situated as side angle side, law of sines won't work with side angle side. And similarly, if I have three sides to a triangle, law of sines will not work. So the point is, law of cosines helps find a missing component in order to then use law of sines. And so here are the three formulas for law of cosines. Realistically, you only need to know one of them because the other two are just the variations of the first one. So the law of cosines says this: a squared equals b squared plus c squared minus 2bc cosine alpha. And then the variations would look like this: b squared equals a squared plus c squared minus 2ac cosine beta, and c squared equals a squared plus b squared minus 2ab cosine gamma. When it comes to these formulas and equations, the labeling of the triangle is insignificant. Let's just recall from the law of sines that when we do decide on how to label it, A and alpha is an angle opposite side relationship, and B and beta is an angle side opposite relationship, and C and gamma is an opposite side angle relationship. So when to use it? We're going to use law of cosines when we are given information that is in a side angle side setup or a side 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 setup. Remember that angle side angle, angle angle side, and angle side side are the setups for law of sines. And so this is reserved for law of cosines. So let's take a look at an example here. We want to solve this triangle. You'll notice that the two missing angles, I've already taken the liberty of labeling them as alpha and gamma. And that's helpful because the 13 would then be A, and the 6 would be C, meaning that the 20-degree angle is beta, and we need the B side. Well, this triangle is set up as side angle side, a perfect candidate for law of cosines. So if I'm looking for the missing side B, I'm going to use this version of the law of cosines. And it's just a matter of substituting my values. And all that this requires us to do, because b squared is by itself, is to evaluate 13 squared plus 6 squared minus 2 times 13 times 6 times cosine 20. I can go to my calculator and I can do that. That's not a problem at all. And I get b squared equals 58.40795. And I just need to square root that. And that's going to leave me with b approximately 7.6. Now, this is the important part. I really only want to use the law of cosines one time. Now that I have this side of 7.6, to find alpha and to find gamma, I'm not going to use law of cosines. I'm going to use the law of sines. And the reason for that is now I have an opposite side and angle relationship. So if I'm looking for alpha, what I would do is I would do the sine of 20 divided by 7.6 is equal to the sine of alpha divided by 13. I'm not going to do that right now because really the only intent here in this problem was to show you, well, how am I going to use the law of cosines? But really only plan to solve these problems with one attempt at law of cosines. And then once you've solved for that missing part, you can go back to the law of sines, since that's a much more user-friendly type formula. In the second example that we're going to look at here, we're going to solve the triangle of a equals 8, b equals 6, and c equals 7. I'm just going to draw an indescript triangle here. This kind of looks obtuse. I really don't know if the triangle is obtuse. I just drew a three-sided triangle. Well, if the 8 is A, then this is my alpha. If the B is 6, then here is my beta. And if the 7 is C, here is my gamma. My approach is simple. I'm going to use one of the law of cosines. For simplicity, I'm just going to use a squared equals b squared plus c squared minus 2 times b times c times cosine alpha. Well, here I have 8 squared, b squared is 6 squared, c squared is 7 squared minus 2 times 6 times 7 times cosine alpha. What I want you to pay very, very close attention to is how I'm going to go about isolating all of this. Since I'm trying to solve for alpha in this case, I'm going to pull these things to the other side. So that's 8 squared minus 6 squared minus 7 squared. And that leaves me with equal to negative 2 times 6 times 7 cosine alpha. Well, I don't really like that, so I have 12 times 7, which is negative 84 cosine alpha. And I'm just going to leave this exactly how it appears. I'm going to divide by negative 84. So now I'm left with this setup. And since I'm solving for an angle, I'm going to do the inverse cosine of this quotient. And I'm doing this on my end on a calculator. I would encourage you to do the same so that we can compare answers and potentially have a conversation on if you did something incorrectly. And when I do that in my calculator, I get approximately 75.5 degrees. And just like in the last example, once I get this angle, now I have a side and opposite angle relationship. So in order to find beta and gamma, I'm not going to do law of cosines. I'm going to do the law of sines to find those missing angles because those are just easier to use with the law of sines. I'm not going to do that here, but I would strongly encourage you to try that. And when you try that, you should get beta to be approximately 46.6 degrees, and you should get gamma to be approximately 57.9 degrees. But if you notice here, when I started with the problem, I had three sides, and I can't do law of sines with three sides, so I have to use this new relationship, law of cosines, to help me get that one angle, and then I can go back and utilize the law of sines. But all in all, this is your law of cosines. Let's try and do a decent job of trying to know this as best as we can. And all the variations are based off of the first one. Let me know if you have any questions, and let's try and sort this out together. Good luck.